Okay, so this is page 8, annuities. You can think of an annuity as a reverse mortgage. Rather than borrowing a certain amount from the bank and being charged interest. In an annuity, you invest a certain amount of money and the bank pays you with interest. So you're going to give the bank money, and they're going to give you back more money than what you gave them because you get that interest on it. It's still going to work the same way, y'all. We're just going to have to pay attention to who's paying who. Up until now, we just kind of always put the numbers in. Now we've got to start paying attention to who's giving who the money and how's it coming back out. Okay, so there is $240,000 in an annuity fund on the day of Mina's retirement. If the fund pays 3.2 interest rate per year, find the value at the monthly payments made to Mina if she plans to withdraw the money from the annuity over the next 20 years. So, we're drawing this out for 20 years, and we're doing it monthly. The interest we're being paid is 3.2. The present value is $240,000, and we want to know the payment, right? And the future value is going to be 0, and we're doing 12 payments per year. Right now, you're like, well, I don't notice anything different. Yeah, pretty close to the same. Here we go, 3.2, 240, 1, 2, 3. What's going to happen? Oh, we're not doing 4 this time. Oh, I'm going to put 0. Doing 12 payments. What's our payment? Alpha solve. And we got 1355.19. Notice it's a negative. We didn't really point that out much before. I mean, really, it's pretty much the same thing, right? You're investing $240,000. The bank is going to pay you back. But the interesting thing about this is the payment to Mina, because the bank is paying her, would be $1,355.19, and it would be in euros or pounds. I think that one's pounds. But the thing is, I don't know if I asked it, if the fund pays this, find the value. This is the monthly pay. Let's figure out how much Mina's going to actually get back. If she gets back $1,355.19, and she's going to get 240 payments of that, even though she invested her retirement of $240, how much money is she actually going to get back? This is what's interesting about annuities. So 1355.19 is her payment. She's going to get 240 of those. She's getting back $325,245.60. That is quite a bit more than she invested, isn't it? So that's where those investments, the higher you can get this interest rate, the more money you're going to get back on that retirement. All right, Jana retires when she is 70 years old. She has $800,000 in her, in her annuity plan, which pays 4.7% interest rate annually. She plans to withdraw $4,500 per month with the annuity account until it runs out. Let's stop there. Let's fill in what we know. We know that her present value is $800,000. Okay? We know that she plans to withdraw. So we need to be sure on that payment that we put in negative because she is withdrawing that money out. That $4,500 is coming off of this $800,000. The interest rate is 4.7%. The future value, it's going to run out. So let's take a look at this. It doesn't really tell us the number of years, right? It did tell us she was 70 years old. That's not the number. That's just Jana's age. Calculate Jana's age to the nearest year when the annuity count runs out of money. How many times can I take $4,500 out of here while I'm still earning 4.7% on this every year? But I'm going to take this out. So I need to figure this out. I don't know the number of years. So here's what we're going to do. Go to apps. I'm going to leave 240 there just so that I can work because it won't let you move if you don't. 4.7, 800, 1, 2, 3, negative 4,500. I'm going to run out of money. I'm paying myself every month. Okay. I'm going to go up here and hit clear. I need to figure out what's that number. So alpha solve. Okay, so here's what I know. I know that when I used my calculator, I got n equals 304.859. Okay, I'm going to take a look at this. I'm going to use this number right here. I'm going to go to quit. 304.859. Remember when we did the numbers, we'd always do some number, I'm just going to put a number, times the number of times we compounded it, right? Which is monthly. I need to divide this by 12 to figure out what was this number here, what was n before I multiplied it by 12. So I'm going to take that number, I'm going to divide it by 12. It's 25.4. So that means that n equals 25.4. The 4 would not change the 5. So really, I'm going to say that she needs 25 years, paying herself $4,500 before she runs out of money. So calculate Jana's age to the nearest year. Well, let's see. She's already 70 years old. I'm going to add on that 25 new years. She would be 95 years old when she runs out of money. Okay? Find the maximum monthly withdrawals she can make if she wants the annuity to last until she's 100 years old. Okay? Well, everything's pretty much the same. The difference is that number of years. She's already 70, so if she wants to last to 100, I need for n to last for 100. So that means the n right here would be 30 times 12. So we're going to go back over here to our app. I'm going to go here and I'm going to change this to 30 times 12. 30 years, getting one withdrawal every time. Oh, what was the actual? Find the maximum monthly withdrawals she can make. So that means I'm going to have to do it a little bit different. So now we don't know this, right? We don't know the payment. Find the maximum monthly withdrawal. What's the maximum amount she can withdraw if she does this? Remember that up here, just to put it up there where it was. Oh, it won't let me move. Okay, it was 30 times 12. Okay, so here we go. Alpha y equals. So the maximum payment that she could make to herself to make this last until she's 100 is 4149.10. That is the maximum monthly amount she could withdraw. All right, and I think that, we got to check for understanding now.